All right, so for this second part of the data visualization lab, we're going to look at categorical variables. Specifically, we're going to look at the weights of chickens as related to the type of feed that they were fed. The reason that we're doing this is honestly because it's a good way to show how to deal with categorical variables, and R has a data set built in for it. So the data set, you've already loaded all of the packages, but in case you're coming to this with a brand new screen, go ahead and load the packages that are in the written lab, which are ggthemes, tidyverse, Dippler, and Lubridate. All right, so we're going to start by looking at the chicken weights data set. So we're just going to say question mark, and chicken weights. Weight. Run that. And it is a weight of age versus chickens on different diets. And you can go ahead and click here and learn more about how this data was collected. All right, so we're going to load our data chicken weight, just as we've been doing. And we're going to look at it just to make sure that it's what we are expecting. I'm going to call summary, just to get an idea of the variables. It looks like we have weight, we have time, which is days, the how many chickens, and the diet that they were fed. And it looks like there were 4 diets. This is going to be our categorical variable. All right. So first thing we're going to do is set a base plot. And I'm going to call it chicks. We're going to assign it to ggplot, and the data will be chicken weights. And the aesthetic, we're going to say x equals chicken weight $ weight. You actually don't need the chicken weight $ part. You could just put weight there because it knows it's coming from that data set. But just to show you another option. All right. So remember, that's only the base plot. There's no geometry there. So if we actually want to see a geometry, we're going to have to assign it. Now, the base plot that we have called only has an x value. So what we really want to know is a distribution of the weights. We're doing some exploratory analysis of this data set just to get a sense of what's there, what it looks like, and things like that. So we're actually going to use a quantitative variable to start. So we'll call chicks plus, we're looking for a histogram here. So we'll type histogram, go ahead and plot that. All right, so we got this warning from R that says stat bin is using bins equals 30, pick better value with bin width. We're going to get to that in just a second. But for right now, what I'd like us to look at is this quantitative variable, not this qualitative variable, so it's not categorical, this is numerical. And this is how many chickens are at this weight, at this weight, at this weight, all the way down to the largest chickens. There's some interesting things here. It looks like most of our data is for very small chickens, and it like slowly tapers off, except for these chickens, which are very, very small. So we might make some assumptions about the age of these chickens. If this was, this could be measurement error, things like that. So we're not quite sure what's going on here, but we do notice that it's something interesting and kind of not what we were expecting in the data. All right, let's go ahead and deal with this warning that R is giving us, right? So the way that we do this is we look at the range of chicken weights, okay? And then we take the difference of the range, and we're going to divide it by 40 because we're going to say, okay, R didn't like 30, let's try 40 bins. So we're going to call diff and then range of chicken weight $weight. So what we've done here is we've specified the range of the chicken weights. So this is probably like 60 to like 300 I don't know, 380, I guess. Actually, this is like, not 60, closer to like 30 or something. So like 30 to like 300 and something, right? So that's our range, and the difference there is like 300 and, I don't know, whatever this is, 350. We're going to divide that by 40, saying, hey, we want 40 bins. Okay, and we get 8.45. So we are going to say, we're going to call our chicks plot. We're going to add the geom histogram, and then we're going to say bin width is equal to 8.45. When we get to the machine learning lab, this technique of taking the range and dividing it by a certain number of categories is going to be an absolutely crucial way to deal with different types of variables. So let's say we wanted to look at the correlation between chicken weight and age. Those actually are not in the same measurements. So in order to deal with that, we'll do something very, very similar to this technique. So this taking the range and then dividing it by however many classes you want is really conceptually very common throughout the real practical statistics, like just simple statistics that you report in a, very straightforward study. All right, so now that we have given it 40 bins, you'll notice something really interesting. This data set here, so this bin here, is much, much, much smaller, right? And the second bin that we were working with is much bigger. Okay, what's going on here? So some of those chickens in this first block were obviously grouped into the next block, making the smallest block here much smaller. So this is something to be aware of whenever you're making histograms, or really whenever you're dividing something into bins, that the number of bins that you use can radically change what your data looks like. This is still a really interesting data point here, but now that the majority of these have been grouped into the next category, we say, that's even more interesting because these are probably outliers or measurement errors or something like that. Whereas the others, we couldn't say that that whole group was an outlier. Okay, so this gives us a great view into the distribution, but we want to investigate weight as a function of diet type. So this time we're going to make another histogram, but we're going to fill each bin with the color of the diet. Diet is our categorical variable that we're going to care about here. All right, so we are going to, we actually can't use our chicks data plot anymore, or our chicks base plot anymore, because we want our fill to be another variable. All right, so we're going to call ggplot, and we're going to pass it chick weight, and then our aesthetic is going to be x equals weight, and fill is factor diet. Okay, so you'll notice that we had to specify that it was a factor. What that does for R is it tells it, hey, there's like a couple of categories here, and I want you to treat those categories as distinct units. So when you use a factor, you say, hey, there's group 1, group 2, group 3, group 4, as opposed to a character or a string, which are infinitely diverse, right? So factor says, hey, I'm using letters to signify, or numbers, to signify that there's a bunch of different groups here. Okay? All right, so we are going to say, all right, make yourself into a histogram. So we're going to pass the histogram, and here's where it gets a little confusing. The aesthetic for the histogram is going to be y equals ... count ... divided by sum of the count. We'll break that down in just a second. Bin width equals 8.45 and position equals fill. All right, so I can already look at this and I'm pretty sure that I have one too many parentheses there. There we go. All right. Okay, so I'm going to expand this so we can see it a little bit better. There we go. All right, so what we've said here, the first line should be pretty familiar by now. We have our ggplot, our data is our chicken weight, the aesthetic, X is the weight, and fill is the factor of the diet. So we have these groups that are within the diet. All right, and then we're passing this geometry. And this geometry says, here's the aesthetic, and for the y-axis, which is here, what we want to get is, let's say that like half of these chickens were fed diet type 1, a quarter were fed diet 2, and a quarter were fed diet 3. Okay, so that's what we're aiming for. That's what this code is going to get us. Okay, so the aesthetic says that the y is equal to the self count. That's what these two dots refer to. They say for whatever the other variable is, count yourself. Okay, so normally it would just be like, you know, count them up, but here we're calling it to be self-reflective. So we've already called our variable here, and we're saying, hey, from within this variable, count each unit separately. Okay, and then it's the sum of the self counts. So it's adding all of these up. This is basically the sum of all of them. Right, so count yourself for each factor. So this says count for factor number 1, count for factor number 2, count for factor number 3. Right, so count for each unit. And then add those all up, and this will give you the percent of whatever this column is, right? So it's a little bit tricky, but you will see this self-referential counting pretty frequently when doing visualizations with R. All right, we're going to keep bin width the same, and the position is that we want it to be a fill. And what that means is that it's going to fill all the way to the top. So we're going to get one of those kind of like crazy waterfall looking pictures. So it's basically going to be a like percentage for each weight. It's not going to be, you know, half of this one and half of this one. Fill says fill it all the way to the top. You'll see what that looks like in a second. All right, so let's go ahead and run this. And it's giving us this warning that it removed 8 rows containing missing values. Those are here. There's not enough information there. All right, cool. So we have this like cool looking waterfall thing that shows us kind of some trends about our feeds. All right, and what we're looking at is the percentage. So it's like 100% for each one. Remember, we only had like one outlier here. That both of these two outliers, so this one and this one, are very fat chickens, and they were both fed diet number 3. We also have the chickens over here. This one was only fed diet number 3. We have a lot of diet 3 here. We have very little of diet 3 over here. This one chicken that was either an outlier or a misrepresentation was fed diet number 1. You probably want to throw that data point away because it misrepresents diet number 1. But overall, it doesn't look like any diet is overwhelmingly good at making fat chickens, except maybe diet number 3. but we'd want to look at a more quantitative visualization of that. All right, so looking at this gives us kind of a first view into the weight of our chickens. Honestly, it kind of just looks cool and represents something numeric about the data. So this, I should never advocate for this, but I always do. You know, sometimes there is a place for these kinds of visualizations that just like look really pretty, but like don't actually tell you the whole story. And this is one of those, and that's not the end of the world. All right, so let's go ahead and see what it would look like as a more traditional histogram, where each bar is just filled in based on the weight. We're going to copy this line of code. We're going to paste it down here, and we're going to remove position equals fill. And we'll get pretty much the same thing, but here we're going to see that like each bar is like broken up by the color. Or each bar, like the number of chickens at each weight is broken down by the color. It's actually a percentage, but it maps pretty closely to the number. I personally find this a little bit harder to read, but this might be more representative. I don't know. It depends on what your goal is. All right, so we are going to move on. We're going to move away from our histograms, and we are going to move on to a scatter plot. All right, this is probably going to tell us something a little bit more direct about our data set. All right, so we are going to call ggplot, and we're going to pass our chick weight, and then our aesthetic is going to be x equals time, so how old they are, and y equals weight, so how fat they are. And we're just going to do a jitter here. Geom jitter, and alpha, I'm going to say alpha equals 0.6. Okay, run that, and we see that we have some clusters over here, and they spread out and get a whole lot more spaced out as we move towards older chickens, right? So we see the young chickens are kind of all the same weight, and the older chickens have a much greater variety of weight. Now this, once we visualize it along with the diet they were fed, this will actually start to tell us if the diet number 3 helps make fatter chickens when they are more mature. All right, so it's our first phase of this. So let's go ahead and add to this the color. I'm going to be lazy, and I'm going to copy this code below, and I'm going to add here in my aesthetic color equals diet. Okay, and here I'm also going to add a stat smooth, so I'm going to add a line of best fit. So I got a stat smooth. Method is a linear line. I don't want to look at standard error because it's kind of hard to see. And I'm going to make the color gray. Okay, so we'll run that, and we see actually something a little bit more interesting. We see more of diet 3 up here with these fatter chickens, and more of diet 1 down here with these thinner chickens. And we see that overall, most of the older chickens that were fed diet 1, maybe diet 2, are below this regression line. They're below this line of best fit, which means that really they're below the average. So if your goal is to have fat chickens, diet 1 diet 1 is no good at all. You'll get a couple of fat chickens, but mostly you'll get skinny chickens. Diet 4 seems to give chickens right on the line. Diet 4 is the average diet. But diet 3 overall seems to give us fatter chickens, and it gives us fatter chickens a little bit quicker. So if, like I said, if the goal is fat chickens, you probably want to go with diet 3. All right, let's look at one more thing that's going to make it a little bit easier. We're going to facet this, right? So you can kind of get a sense of the trend here, but it's going to be much easier if we do a facet grid. I'm going to copy this code. I'm going to put it below, move that down so it's easier to read. And I'm going to add a facet grid. I'm going to add it before the stat smooth line. And I want it to facet by diet. So I want to break each diet into its own panel. Okay. So all I did was I copied the code, I added facet grid diet and a plus sign, and we will go ahead and run that. And we see that overall diet 3 is the winner, but it's not as much of the winner as we might have thought to begin with, right? So diet 3 does have more fat chickens, but it's not as extreme as we might have assumed looking at this plot. All right, so there's a couple of issues here. It's really clear that a linear model doesn't fit the data. We'll deal with that in a future lab. We will also, in the previous lab, you learned some techniques for making this much prettier. Honestly, the backgrounds here kind of make it difficult to read. But for the purposes of breaking down by a categorical variable and working with ranges, you are ready to go out into the world and visualize your categorical variables. All right. So if you're interested in time series, go ahead and move on to the next one. Otherwise, please just submit this final graph. You can export it here, save it as an image, and send it to me just as a PNG or a PDF. I don't care, or JPEG. All right. Thank you much, and I look forward to seeing you in the next lab. All right. Bye-bye.